Should I explain anything?
Let me explain with let me understand with the test case. So it's provided the first row is 1 2 3 4, second row is 5 1 2 3, and the third row is 6 5 1 2. And when we are moving from left to right, every left to right descending diagonal has the same element. Like suppose I am at left to right descending diagonal. So can you explain me the question? Like I'm not able to get it.
So let's say you have a matrix, say 1 comma 2 comma 3,
Yeah.
and in the next section you have some 4 comma 5 comma 6,
Mm.
and in another treat it as a single matrix, and those lines, those in the brackets as separate rows. Okay,
Okay.
7 comma 8 comma 9. So what the question is saying is, if you stand at an index I,
Mm.
I mean I comma j
Mm.
is a matrix, so we have to represent it in a 2D shape. So I comma, if you are at I comma j, then let's say the size, overall size, the matrix size given is m into n into m. Sorry.
ठीक है.
Okay.
Okay.
So I said you are at I comma j. So what you will do is, from I comma j, you will go to I plus one comma j plus one. Okay. And from this I plus one to j plus one, you will go to I plus two comma j plus two
Okay.
till,
I'm
yeah.
not asking the
Let me
answer.
explain.
Like, can you explain me the through?
No, no, no. That's what I'm saying. That that's what I'm explaining. If you are at any index I comma j, you can go to the diagonal indexes. That's what I'm trying to
Okay.
explain here. So
Okay.
its diagonal indexes are these now. So the every element on this diagonal index should be equal. If it is satisfying for every I comma j in that matrix, I mean there will be total n into m values no in a matrix.
Uh,
So this condition should satisfy for every element in that matrix. Then only it will call as that Toeplitz matrix. Otherwise, it is not.
okay, I
So
got
that's
it.
the point of the question. Yeah.
So um, I'll okay. So here I'm thinking of that. I'll firstly start from 0 comma 0, and
Yeah.
I will take two variable. Uh, that will
Mm.
be one will be keep the row and row number, and one other will be keep the column number.
Yeah.
So and I will keep a like I can keep another set that will keep my like element that can keep my element. So I'll
Mm.
move from like 0 comma 0 to 1 comma 1 2 comma 2 3 comma 3 until I reach to the end of the row or column, until
Okay.
one of the variable row or column is exceeding, means going
Yeah.
out of bound. So I will
Yeah.
push all those elements in an unordered set, and at the last I will check if this set has size equal to 1. Then that means all the elements in that diagonal is same. Otherwise,
Yeah.
if the size of that unordered set is not 1 or greater than 1, that means it's not a Toeplitz matrix, because it's not all elements are not same in that diagonal.
Okay.
Am I Are you able to understand what I'm saying?
Yeah. Yeah. I understood a little bit. Can you write that code so that
Okay,
I can?
so let me firstly find the number of rows which ARR has. Like if total rows is ARR of ARR dot size will give us the row number of rows, and number of columns will be ARR of 0 dot size. This will give the number of columns present in the this matrix. And I'm taking two variable
Okay.
like uh, row one means row and column, which I started from 0,
Yeah.
and I will take another set which will keep all the elements. So I'm taking that has asset. So for all the means I'm traversing from, let me check. Let me keep a while loop. It will check if
Yeah.
row is less than rows. Rows means the maximum number of rows, and column is less than calls means maximum number of columns. This row or column
Okay.
should not exceed the row size and column size respectively.
Yeah.
So here I will
Okay.
push the given value in, sorry, array of row comma column. Here I'll push and I'll increase row and column by one. And at the last I will
Okay.
return that if this has set has size 1 or not. So I will return has set dot size equal to 1. So let me dial in. Okay. Wait a minute. I, I think the question was not able to understand the question correctly. Actually, the question is that different. I have to check for all the columns. Okay.
Yeah.
Yeah. I was wrong. So actually, wait a minute. I should not check uh, means the middle column, the middle diagonal. I have to check all the diagonal like uh, size
Yes.
diagonal having size 1, having size 2, having size 3, like that. I have to check all the diagonals.
Yes.
So, but
Yes.
there was a mistake in my approach. So I'm trying. I'm Let me think of the other approach that I can do. Give me a minute to think.
Yeah.
Okay, so I'm thinking like that, that I'll start from like the last row. Like here,
Mm.
if given in as given in the example, I will start from the last row. That here I will start from the two comma the second row and the zeroth column is 2 comma 0, and I will find all the number in this diagonal. Okay.
Yeah.
So, and I will keep all this number in the hash set which I was doing earlier for only one diagonal. So I will
Okay.
do for all like then after I'll go to then I'll go upward like I'll check for the n minus second row. Then I'll go to the n minus third row and then I'll find all the diagonal. Similarly, I'll do like that. And after
Yeah.
going
You do
further
one thing.
backward,
Just, you do one thing. You write your code and you walk me through your code. Means, you explain me everything in that code only itself. Okay.
okay,
I think that would be a good idea.
okay.
Okay.
So
Any mistake, we will clarify at that time only. So it will be there.
so
So
let
you
me
write your code. I will check.
column will be 0. So while row is greater than equal to 0, I will do this. Like I will define a extra variable like row 1 is equal to row and column 1 is equal to col. Um, okay, so yeah, column 1 will call, and I will traverse through traverse like while row 1 is less than rows and call 1 is less than call. So, and here I will use ordered set of integer, that is has set, and I will insert all the number in this diagonal in the hash set, that is um, ARR of row 1 and column 1, and I'll increase this row 1 call one by one. Okay. So after that, if this has set size of hash set is greater than one, then I'll return false from here only because I don't need to check further. After that, I will decrease this row one by one because I have to check the upper row, like the
Yeah.
diagonal which is starting from the upper. After that, I traverse through all through the first columns. Then I will start from the first like first row starting. So again, I will change the row to 0, and the call variable will be like 1. I'm starting from the first because I've already checked the 0th index. So again, I will keep the condition like when call is less than calls, while means column is less than the maximum size of the column.
Okay.
And I will define this in similar way like row is equal to row and call one is equal to call. And while row one is less than rows, and call one is less than calls. So here also I will use another set to check for the same element, like this not element. So
Okay.
I'm doing this. I'm copying from the above the code, and again doing the same thing, that if the hash set is greater than 1, then I will return from false from there only. No need to check further, and I will increase the column by 1, and I'll return, and at the last I'll return true, that as I've checked all the diagonals. So
Okay.
let me dry run it. Like, so when I will start from using the given matrix, that is of 3 cross 4. So
Yeah.
initially the rows are will be 3 and calls will be 4, and I'm initializing row with 2 and call with 0. So I'm firstly going inside while loop, and as row is greater than equal to 0, so I am redefining row 1 to 2 and call 1 to call that is 0. Okay. So then after I'm taking a hash set. After that, I'm checking that row one is less than rows and call one is less than calls. Then it will insert. Then it will insert all the elements along that diagonal, and that will also increase the row one column one. After that, I'll check the hash set. Then after I'll decrease the row one, means to the next row, and after that, for the column side, means the top row side, I'm using row number is equal to 0 and call as 1 because I'm starting from the first column, and while call is less than columns. Okay, so again I'm defining row 1
Mm.
as row and column as call. So after that I'm using hash set in similar way, and again row 1 is less than rows while row 1 is less than row and call 1 is less than calls. I'm inserting into hash set the row 1 and column 1, and I'm again increasing the row 1 and column 1. So after that, I'm uh, inside checking if the size of hash set is greater than 1. That means all the elements are not same. And again, I'm increasing the call, which is yeah. So I'm increasing the call, and after all the checking done, I'm returning true from there. So I think this is the approach, and I have to import like set for using the another set. I think this might work. think there might be some error due to the while loop. Oh, sorry. Yeah, it got passed.
Can you explain me the time complexity and space you're using?
Okay, so I'm as I am traversing all the column like only once means okay. So um, actually I'm traversing all the elements only once.
Yeah.
So the time capacity will be like O of n into m. That means the matrix size. And yeah, the matrix size. And space complexity, as I am using a hash set. So for all time, space complexity will be the same like O of n into m.
Yeah, yeah. Do you have any other approach or is the final?
Okay, let me think. Yeah, I'm thinking to reduce the space complexity.
Oh,
Yeah, like I can keep the last keep the last variable which suppose I'm keeping the zero comma 0 variable in another variable and after when I'm moving to the next next value like in the same diagonal, then I'll check from the previous value that if it is same or not. If it's not same, then I'll break from there only. It will reduce the space complexity. Like then we don't have to use the hash set.
yeah.
So are you getting?
Or you, yes, yes, you can reduce the space complexity by that. That's fine.
Yeah.
Okay.
And
The time complexity seems to be under the constraints satisfiable. So
yeah,
I think the space complexity will be reduced by the idea you have given.
and
So one more thing,
yeah, yeah.
yeah,
Actually, I
if
don't
you
have
can
any idea
observe,
to reduce the time complexity.
yeah, yeah. I, that's what I said. The time complexity is under the constraint. That's the most you can minimize the time complexity because. So do we have to use those two while loops? Is it necessary, or we can do? I mean, what I mean to say is, you are using two into n into m. That's the complexity, right? Because we have
No,
inside two
no.
loops, while loops.
I'm only traversing the whole matrix once.
Yeah, but there is two while loops there, you know.
Yeah,
So if I,
there is two values, but I'm not traversing the whole matrix twice. I'm only
okay,
traversing the whole matrix once.
okay, sorry, okay. This and this is different, no? That's the rows greater than variable zero and
Mhm.
call calls are the okay. It's in square. Okay, okay, it's fine. It's fine. No, solution is fine. Yeah, we can reduce the space complexity. Uh, yeah, you can check it by checking the values without anything.
Actually,
Like
your
you can
voice is
maintain
not
a
clear.
variable. Sorry,
Actually, your
hello,
voice is not clear.
audible. Hello,
Hello. I think there is some noise coming from your sound side.
hello, hello, hello.
Can you try to reconnect or can you refresh the page?
Can
Hello.
audible.
Yeah, yeah. I think it's better.
Yeah, what I'm trying to say is in the space complexity section, we can maintain a variable and
Yeah.
store it with array of row 1, column 1. So we have a property in XOR that if the number of elements is even, we will get an answer as 0. The same value, if we are XORing the same element even number of times, then the output will be 0.
Mm.
And if it's odd, then the output will be the element in the beginning itself.
Mm.
So what you will do, so I'm just telling how you can improvise the space complexity. That's what. Uh, Apart from that, the logic is fine.
Yeah.
So what
Um,
I had in my mind is, uh, from my point of view, if I had to explain the solution, what I thought is, if you think, if you observe the overall matrix, the difference between the row value and column value will be constant, no? I mean, if we are at I comma j position and we are traverse and we are going to next position at I plus 1 comma j plus 1, the difference will be constant for every diagonal element.
mm.
So what I want to say is I will create a linear, or you can say a linear array of size. Here they are mentioned the length won't be exceeding 20. So I will create a linear array of size 21, which represents the difference of the column values, each individual column values. So now I explained to you that we can maintain a variable and we can sort to store the value whether they are equal or not. So according to that, that array some, let me, you can see that, right? You have array of 21, right? So what this array will store is array of 0 will store all the elements whose row value and column value difference is 0. It will store the XOR value of all the XOR value of it. So by that we can slightly reduce the number of lines of code we are writing. That's what the overall
Yeah.
complexity will remain the same.
Yeah.
But
Can reduce the number of
point of my
line.
point of view, the code will look like that.
Yeah,
So
I
did
got
you
it.
understand my approach?
Yeah, yeah, I got it. Like
They haven't mentioned that
I am
approach, but
using the
that's
properties of JOR. Uh, That's the joring the even number of times, like joring the
what.
same number of times, even times, will give us
Yes,
0, and odd times will give the same number. So we are
yes,
using
yes,
that property, right? Yeah,
yeah.
that will also work. Yeah, I got it.
Okay, I think we are in the end of the discussion. So if you have anything, I don't think that I have something to say to you because you are already experienced than me in this platform. So
So
I'm waiting
any
for your response to.
any feedback
Mm,
for me, like
yeah, that's what I'm saying. I don't think